take a look at this expression here. We're at the antiderivative of x cubed times sine x dx. Okay. Now, we know where we're going with this already. So if we have u and v, we can see that our u is going to be the x cubed, and therefore du is 3x squared, and dv is going to be sine x dx, and v is going to be the opposite of the cosine of x. Okay. So if we were then to put that into our parts that we know about, we know that our answer is uv, so we have negative, or the opposite of x cubed cosine x minus the antiderivative, and now it's v du. So that's going to be negative 3x squared cosine x dx, and then we're going to have to do it again. But think about it. When we do it again, this now becomes 6x. And when we do it again, it becomes 6. So we have a lot of iterations to go through. So in a situation when you have a lot of iterations, sometimes it might be easier to try this method, this tabular method, if you will. Okay. And here's how it works. You need 4 columns. Okay. You need a lot of rows, depending on just how high your exponent happens to be. Okay. Because of the whole anti-deriving, and the negatives of the negatives, basically our plus and our minuses alternate, all right? The first row we're going to leave almost entirely empty. But then the second row, we're going to start doing plus or minus. It's going to alternate, and you always begin with plus. So we got plus, minus, plus, minus, plus, okay? Then we have our u and our du column. We already know what u is. The first time we picked u, it was x cubed. So we're going to put that in the u column, all right? And we're going to stick it specifically in the second row. All right, so we have our x cubed right there. All right, and what's going to happen is we're going to differentiate this entire column. All right, so what's the derivative of x cubed? 3x squared. So what's the derivative of 3x squared? 6x. What's the derivative of 6x? 6. What's the derivative of 6? It's 0. All right. These are all going to be a part of our answer. Now we go to the dv column. Initially, dv was sine x dx. That actually goes in the first row. Right? And now, think about it, because it's dv, and we want to get to v, we're not going to derive it like this column. We're going to integrate. Right? So this column gets integrated. All right? So the antiderivative of sine is the opposite of cosine. The antiderivative of the opposite of cosine is the opposite of sine. The antiderivative of the opposite of sine is cosine. The antiderivative of cosine is sine. The antiderivative of sine is the opposite of cosine. All right? So you're doing a bunch of quick antiderivatives. If we multiply across, the sum of all those products is going to be our solution. So we're ignoring the top row, right? But if we go to the second row, we have 1 times x cubed times the opposite of the cosine of x. So that's the opposite of x cubed cosine x. And then we have negative 1 times 3x squared times the opposite of sine x. So the two negatives will eliminate each other, and we have 3x squared sine x. Right. Then we have 1 times 6x times cosine x. So 6x cosine x. And then we have negative 1 times 6 times the sine of x. So that's minus 6 sine x. And then we have 0. 0 times anything is 0. We need to fill that in. All right. These 4 terms right here, that's going to be our answer if we just add them together. So our final answer will be the opposite of x cubed cosine x. Hey, look, it's right there. Okay. So we were going to get to it eventually, but this way seemed to go much quicker, right? Plus 3x squared sine x plus 6x cosine x minus 6 sine x. And then because we took an antiderivative and there are no bounds, we need our plus c. We need our arbitrary constant. And this value right here is the actual antiderivative. Believe it or not, if you derive this boxed off expression, you're going to end up with x cubed sine x, because you're going to get one, from the product rule, then everything else is going to cancel each other out after you take the derivatives. It seems that the tabular method might be a quick way to do that. You could do either way. Something like this, extensive, would not be on the exam, but you might see 2 iterations. And if 2 iterations is enough for you, you can do this with 2 iterations.